Hi guys, this is Mrs. Rhodes, and this is video 2 for the week, lesson 2. It is on graphing radical functions with reflections and vertical dilations. And the radical function is actually the square root function. And basically, we like to use values in our domain that work well under the square root. And I'm just going to make a table of values here. And we're graphing, I'm going to call it y, even though it's really called f of x equals the square root of x. And the values that work under the square root are 0, 1, 4, and 9. We can't have negative values under the square root. They're undefined, and we know that 0, 1, 4, and 9 are perfect squares. For 0, the perfect square, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So this is what this graph looks like. It has an endpoint at 0, 0. Then 1 is an ordered pair, 1, 2, 3, 4, 2, and then if I were to go out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, it would be right here. So this is this graph. And that's it. That's the square root function. I'm going to show you a couple reflections. So we have vertical and horizontal reflections, and I'm going to show you the dilations also. So the regular square root graph, this time I'm only going to be using 0, 1, and 4 as my x values, and I'm going to call this k of x. And this is the function k of x. 0 in here is 0, the square root of 1 is 1, and the square root of 4 is 2. So k of x equals the square root of x. So let's go ahead and graph that. That's 0, 0, 1, 1, 1, 2, 3, 4, 1, 2, and this is my square root function. This is a negative in front of the square root sign. This is called a vertical reflection. Whoops. And it means all the y values are going to become negative. So this is also a way we talk about this, is we call the function is reflected over the x-axis. And the reason it's being reflected over the x-axis is because if I have positive y values, 1, 2, 3, 4, this is what the original function is. What's happening is all the y values are becoming negative. So for example, if I make a table of values and I was going to be plugging in 0, 1, and 4, in the original function I would have had a 0, but now this is going to be equal to a negative square root of x. So 0 negative is just 0. But when I plug in a 1 here, it becomes negative 1. And when I plug in a 4 here, it becomes negative 2. So this is my reflected function. So this truly is S of x. And this purple function is the original function, k of x, but I'm actually going to erase it here, because the true graph S of x is right here. It's reflected over the x-axis. And we do use shorthand for this. If you wanted to use shorthand for this, you could say it's reflected over the x-axis. I've used that shorthand with my students before. Now, this equation here is called a horizontal reflection. All right, let me change colors. This is called a horizontal reflection. Or it's called reflected over the y-axis. So if you think about something being reflected over the y-axis, if I have a point here and then I'm reflecting it over the y-axis, or if I have a point here and I'm reflecting it over the y-axis, the x value is changing. So this x value was 2 and now it's negative 2. And this x value was 3 and now it's negative 3. So the x values are changing their sign. And when we think about this and we go ahead and make a table, and this is going to be y equals the square root of negative x, when I plug in 0, 1, and 4, so I'm going to have negative 0 is 0, negative 1, well, that's not going to work, okay? What value, but there is an x value that would work in here, and it would be negative 1. Negative 1 times a negative becomes 1, and negative 4 times a negative becomes 2. So what happens is actually all my x values became negative. if you notice. And so this is this graph, 0, 0, negative 1, 1, and negative 4, 2. So when the negative is on the inside, it's called a horizontal reflection or reflection over the y-axis. And you could use the shorthand like that. And when it's in front of the function, it's a reflection over the x-axis or vertical. It goes down, whereas this one horizontal from the original. The blue one went horizontally. Let's go to the next page. This number in front is called a dilation. And this is a multiplier, and it's basically just multiplying by y values. So let me just show you this real quick. So originally, my original, or actually I'm going to call this the parent function. Here's the parent function. And this is the parent function, y equals x squared. We put in 0, 1, and 4, and we got 0, 1, and 2. But what this is doing is now taking whatever we plug in the x. So for example, if we plug in a 4, it's going to produce a 2, but then that's going to multiply all the y values by 2. So what this vertical dilation does, it takes all my original y values and multiplies them by 2. So if I were just going to make a short table here, I'm going to take 0, 1, and 4 as my inputs. But once I go ahead and plug in these ordered pairs, 0 times 2 is 0, 1 times 2 is 2, and 2 times 2 is 4, you see that I took all these y values and multiplied them by 2. So this is another way sometimes we talk about this, or you could just make a straight table and just plug in these x values, the original domain values, and just get the y values. Either way, the ordered pairs are 0, 0, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. This is now a vertical dilation. Notice it's stretched up. The y values aren't doubled from what they were before. The original function looks like this. So this is the original function, y equals the square root of x. Now in pink, this is y equals 2 square root of x. Notice all the y values are multiplied by 2. This one is again a vertical dilation, but I have a reflection also. So now when I go ahead and look at this, I'm going to take the original x's, 0, 1, and 4, and now I'm going to multiply all the y values, that were originally in this function by a negative 4. So all the original y values are going to be multiplied by negative 4. So it's negative 4 times all the original parent function y values. So this is going to be 0 times 4 is negative 4 is 0. 1 times negative 4 is going to be negative 4. And 2 times negative 4 is a negative 8. You can think of it. You can either, if you want, just plug in 0, 1, and 4 into this function and get, the values. 0 times negative 4 is 0. The square root of 1 is 1 times negative 4 is negative 4. And the square root of 4 is 2 times negative 4 is negative 8. Or you could go up to the parent function right here and just multiply all those y values by negative 4. So that's two ways to do this. Either way, it's 0, 0, 1, negative 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. It's always okay to go off the grid. Okay, and this is j of x. That's its name. When I talk about this transformations, because on the homework I asked you to write the transformations, this one is reflected over the x-axis. That's the first transformation. And the second one is it's vertically dilated. And the right way to say it is by a factor of 4. We never say it's vertically dilated by negative 4 because the negative is actually a reflection. It's not a vertical dilation. Okay, let's go ahead and do one more problem and then you guys can finish the rest on your own. Graph each function on the coordinate grid using 3 or more points. Determine the key characteristics. So I'm looking at an endpoint domain range in the transformations. So this is going to be, when I go ahead and graph this, I now see that this is a negative in the x value. So instead of doing 0, 1, and 4, I need to put in 0, negative 1, and negative 4 because I have to have a positive value in here. So I'm taking the opposite x values that I took from the parent function. And when I make this table, I'm sort of comparing it to the original parent function of y equals x squared. I mean, y equals square root of x. I'll write it over here. So the original parent function is this. So now I'm taking the opposite sign x's, and then all the y values I'm going to multiply by 2. So this is 0, 2, and 4. Or if you wanted, you could have just plugged these x values into this function and gotten your y values. It's your choice. Either way, I'm at 0, 0, negative 1, 2, and negative 4, 4. And this is my function. So this is f of x. It has an endpoint at 0, 0. The domain is negative infinity to 0 bracket. The range is bracket 0 to infinity. And the transformations. We always talk about transformations. Well, we can do the reflections first. We typically go left to right. So my first thing is going to be a vertical dilation by 2, and then a horizontal reflection. That's the negative sign. This was the 2. Okay, so that came from the 2 and that came from the negative sign. Or you could call this reflection over the y-axis. Or write r with a little y. And that's it. We're going to leave you guys to do the rest of this worksheet. The following 3 problems, they're on the next page.